such as adding new elements to an array, finding elements, removing them, splitting and combining arrays, and so on. These operations are extremely important in programming, especially if you are starting out. So make sure to watch every lecture and do the exercises that I have designed for you at the end of this section. So now, let's get started. Start by declaring a constant called numbers, and we set this to an array with two elements, 3 and 4. Now note that here I've declared numbers as a constant. That means we cannot reassign numbers to something else. If we do this, we get this error, assignment to constant variable. However, it's perfectly fine to modify the content of this array. We can add new elements or remove existing elements. So constant does not stop us from modifying the content of an array, okay? So earlier you have learned that arrays are objects. So using the dot notation, we can look at all the properties and methods defined in arrays. In this lecture, we're going to look at 3 of these methods to add new elements to the end, beginning, or middle of an array. The first method we're going to use is the push method. So numbers dot push. We can pass one or more arguments, and these arguments will be placed at the end of this array. So I'm going to pass 5 and 6. Now let's do a console.log of numbers. Save the changes. So we had 3 and 4. Now we have 5 and 6 at the end. If you want to add elements to the beginning of an array, you use the unshift method. Let me show you. So numbers dot unshift. This basically pushes the elements in this array to the right and adds new elements at the beginning. So again, here we can pass 1 or more arguments. I'm going to pass 1 and 2. Now let's bring this console.log down. And by the way, to do this, you can hold down the Alt key and press the up or down arrow. That's a good tip to know, okay? So save the changes. Now we have 1 and 2 at the beginning of this array. And finally, if you want to add elements to the end of an array, you use the splice method. So let's bring this down. Numbers dot splice. With this method, we can go to a given position and add new elements or remove existing elements. Later in this section, we're going to look at removing elements. So for now, don't worry about that. Now look at the parameters of this method. The first parameter is start, which is a number. So that's our starting position. So let's say in this array, after 1 and 2 here, between 2 and 3, we want to add a new element. So our starting position is here. What is the index of this element? Well, you know that arrays are 0 indexed. So the index of the first element is 0, then 1, and here's 2. So our starting position or starting index is 2. Now look at the second parameter here. That's delete count, which is a number. How many elements do we want to delete? In this lecture, none. So I'm going to pass 0. And then look at the third parameter. That's the items we want to add. So to make this stand out, I'm going to add 2 characters here, A and B. Save the changes. So note that A and B are placed after 1 and 2. All right, now let's see how we can find elements in an array. Finding elements really depends if we are storing primitive or reference types in an array. So I'm going to start with primitives because they're easier, and then I'll show you how to find reference types in an array. So let's say we have an array of numbers with 4 elements, 1, 2, 3, 4. Here we have a method called index of. We pass the element we are looking for, and if that element exists in the array, this method will return the index of that element in the array. If it doesn't exist, it will return -1. Let me show you a few different examples. So first I'm going to pass the character A. Obviously we don't have this element, so the result that we will see will be -1. Look, so index of returns the index of the given element in this array. However, if I change this to 1, We get 0 because the index of this element is 0. Note that the type of this element matters. So if I pass 1 as a string here, again, we get -1 because we don't have 1 as a string in this array. We have it as a number, okay? Now, similar to index of, we have another method called last index of, and that will return the last index of the given element or -1 if it doesn't exist. So to demonstrate this, I'm going to add another one here. Now, let's do another console.log numbers dot last index of 1. Save the changes. So the last index of 1 is 3 because it's here, and the index of this element is 3, okay? So basically, to see if a given element exists in an array, we can do something like this. Console.log numbers.index of 1 is not -1. If this expression returns true, that means this element exists in the array. Let's have a look, save the changes. We've got true here. But this is a little bit ugly. We have a new method in JavaScript for achieving the same thing. So console.log numbers.includes 1. This simply returns true if the given element exists in the array. Let's have a look. So save the changes and we get true here. Now all these methods have a second parameter which is optional, and that is the starting index. For example, with index of, let's change this to 1 as a number. So save the changes. You can see the index of 1 is 0 because it's here, right? However, I can pass a second argument here. That argument is called from index. And that's the index at which the search will begin. So I can pass 2 here. So that is 0, 1, 2. Our search will begin here. Let's see what we get. Save the changes. So we get 3, which is the index of the second one in this array. I told you that finding primitives is different from finding reference types. So let's see why. I'm going to start by declaring a new array called courses. And in this array, we're going to have a couple of course objects. So here's the first one with 2 properties, ID and name. The name doesn't really matter. Now we can duplicate this line by holding down Shift, Alt, and the down arrow. So let's change these values, ID 2 and name B. And don't forget the semicolon here. So we have 2 course objects here. Let's see if we have a course with the name A in this array. The includes method that you learned in the last lecture will not help us here. Now, let me show you. So courses.includes. Here we pass the object that we're looking for. So course with the ID 1 and name A. Now let's log this on the console. Console.log. Save the changes. We get false. The reason for this is because these 2 objects, that is the object that we're passing to the includes method and the object that we have in the courses array, these are 2 different objects. They have 2 different references. They're in 2 different locations in memory. And in the last section, you learned that objects are reference types. So when we check them for their equality, the references are checked. In this case, there are 2 different references. That's why we get false. So if you have an array with reference types, you need to use the find method. Let me show you. So I'm going to delete this line. Courses.find. Now look at the parameter of this method. What we see here is way too complicated. So whenever you want to learn about an object or a function in JavaScript, simply search for that. JavaScript array find. Here the first link is from developer.mozilla.org. So that's a good reference. Here you can find a good description of what this method does and a very simple example of using that method. So here we have an array with a few numbers. We're calling the find method. Note that as an argument to this method, we have to pass a function. We call this function a predicate, and we use that to determine if the given element exists in an array or not. So this function takes a parameter that's an element in this array. And in the body of this function, we should return a Boolean. So here we have a simple expression. If this element is greater than 10, we'll return true, otherwise we'll return false. So this is what happens when we call the find method and pass this function. This function is executed once for the first element in this array. So in this case, 5 will be passed here. 5 is not greater than 10, so we'll return false, and the search will continue. Now this function will be called for the second element in this array. So 12 will be passed as an argument to this function, and because it's greater than 10, we'll return true, and the search will stop here. So now, what we'll get here as a result of calling the find method is the first element that matches this criteria. So if we log this found variable on the console, we'll get 12. Now in contrast, if there are no elements in this array that matches this criteria, we'll get undefined. Let me show you. So back to our example, let's say we want to see if we have a course with the name A in this array. So we pass a function here. We call this a predicate or a callback function, because this function is called back as part of finding an element in this array. So here we should have a parameter. We can call that element or course, because each element in this array is a course object. So it's better to be more explicit. That makes our code more readable and understandable. So what is our criteria? We are looking for a course with the name equal to A. So we simply return this. And let's store the result in a constant called course. And finally, let's log this on the console. Here's the course object, save the changes, and that's the course with the name A. We get the complete course object that we have in this array. Now, if I change the search criteria to something like this, X, Y, Z, obviously we don't have a course with this name, so when we save the changes, we get undefined. So here's our find method. It returns the first element that matches this criteria. We have a similar method called find index. It works exactly the same, but instead of returning the actual object, like the course object, it will return its index. Let me show you. So I'm going to change this to find index. In this case, we don't have a course with this name. So when I save the changes, we should see -1 on the console. Here it is. Now, if I change this back to A and save the changes, we get 0 because the index of the first element that matched this criteria is 0. Lecture, you learn about this predicate function that we pass to the find method. In ES6, there is a shorter and cleaner way to write the same code using arrow functions. So whenever you want to pass a function as a callback function or as an argument to a different method, you can use the arrow function syntax. Let's see how that works. So you remove the function keyword, and to separate the parameters of this function from its body, put a fat arrow in between them. This is what we call an arrow function. Now, if your function has a single parameter, you can also get rid of the parentheses. And this makes your code cleaner. You're removing the noise in the code. If you don't have any parameters, you have to pass an empty parenthesis. In this case, we have a single parameter, so I'm going to bring that back. And finally, if your function is a single line of code and is returning a value, you can make this code even shorter. First, you get rid of the return keyword, and then you remove the curly braces, like this. And finally, you can put everything on one line. So here's the end result. We read this expression as course goes to course.name equals A. So basically, we are finding a course with the name equal to A. All right, now let's see how we can remove elements from an array. So start by declaring a new array, numbers, and we set this to 1, 2, 3, 4. Earlier in this section, you learned about 3 methods to add new elements to an array. You learned about the push method, which we use to add something at the end of an array. you learned about the unshift method that we use for adding elements at the beginning of an array, and the splice method that we use for adding an element somewhere in the middle. Now, when it comes to removing an element, again, we can remove an element from the end, from the beginning, and from the middle. But instead of the push method, we use the pop method. This will remove the last element in this array and return it. So let's store that in a constant called last. And here I'm going to do a console.log of numbers, so you can see the array after we pop the last element. And also I'm going to show you this last element. Save the changes. So here's our array, 1, 2, 3, and you can see the last element is 4. Now, if you want to remove an element from the beginning, you use the shift method. Similar to the pop method, this will return the element that was removed. So we can store that in first, and let's have a look here. Save the changes. So the first element is 1. Now, if we log numbers, we only have 2 and 3. Pretty easy. And finally, the splice method, you learned about that earlier. So if you want to remove an element somewhere in the middle, you pass the index of that element. So let's say we want to remove this 3 here. The index of this element is 2. So we pass 2 here. And as the second argument, we pass the number of elements we want to delete. We can remove one element, and then let's log this on the console, numbers, save the changes. Actually, the result is confusing. So I'm going to comment out these 2 lines so we work with our original array. Let's have a look. So note that 3 is removed. We have 1, 2, and 4. Now, if you want to delete multiple elements, you pass a value greater than 1. So we can delete 2 elements starting from index 2. Save the changes. So 3 and 4 are removed, and we only have 1 and 2. So to recap, use the pop method to remove the last element, the shift method to remove the first element, and the splice method to remove an element somewhere in the middle of an array. So now you know how to remove an element from an array. But what about emptying an array? How can we remove all the elements in this array? Well, there are a few different solutions. Here's the first solution. We can simply reassign this to a new array. Now in this case, because we have declared this array using const, we cannot do this, so we have to change this to let. Now let's log numbers on the console. Save the changes. So now our array is empty. However, note that this old array is still in the memory. So if there are no other references to this object, eventually it will be removed by the garbage collector. So this means if we have, let's say, another variable called another, and this is also pointing to the same object, this original array will not be garbage collected. So on line 6, when we reassign the numbers variable, now numbers is pointing to a new object in memory, but another is still pointing to the old object. Let me show you. So here, instead of logging numbers, let's log another. Save the changes. So we can see another is still pointing to this array, to the original array. But if you look at the numbers, numbers is now pointing to a new object, to a new empty array. So this solution works if you do not have any other references to the original array. If you do have multiple references to the original array, then you need to use one of the other solutions. So I'm going to comment this out. Let's look at solution 2. We can simply set the length property to 0, and this will truncate the array. It will remove all elements. So here we're logging another. Let's also log the original array. Save the changes. You can see the original array is truncated, so it doesn't matter how many references you have to that array. So here's solution 2. The other solution is to use the splice method. So in the last lecture, you learned that with the splice method, you can go to a given position and remove one or more elements. So we can start from the first element and remove all elements in this array. How many elements do we have in this array? Well, that is numbers dot length. Okay, save the changes. Again, both arrays are emptied. And finally, the last solution is to use the pop method. So solution 4. So you learn that the pop method removes the last element in this array. Now we can put this in a loop and keep calling this method as long as we have an element in this array. So while numbers.length is greater than 0, we can keep popping elements. Save the changes. Again, both arrays are empty. Now, this last solution is not something that I recommend you to do, because if you're dealing with a large array, let's say if you have 1,000,000 objects in this array, there's going to be a performance cost. You're essentially calling this pop method 1,000,000 times, okay? However, that's not the situation with most applications out there, unless you work for Google. But in terms of clean coding, you can see this approach is pretty noisy. Compare that to the first solution. This is very simple, elegant, but the only issue it has is it doesn't work if you have multiple references to this array. So my personal preference is to set the length of the array to 0, but the first solution is also perfectly valid if you have a single reference to your array. And finally, similar to the last solution, you can see solution 3 is also a little bit noisy. So overall, I would go for either solution 2 or solution 1. All right, now let's see how we can combine two arrays or slice an array into two parts. So let's start by declaring two arrays. Here's the first one. We put 1, 2, and 3 here. And here's the second one. I'm going to add 4, 5, and 6. To combine these two arrays, we use the concat method. So first, dot concat. This will basically concatenate the first array with the second. Now both arrays are unaffected, so this will return a new array, which is the combination of the first and second arrays. So let's store the result in combined and log it on the console combined. Save the changes. So we get 1, 2, 3, 4, 5, 6. Pretty easy. Now we have another method that is the opposite of concat, that is slice. And we use that to slice an array into two parts. So let's get the combined array and slice it. Now there are multiple ways to use this method. One way is to pass a zero-based index for the start and end. So we can start at 2 and finish at 4. Let's see what we get. So let's call that slice and log it on the console. So this is what we get. We went to the combined array, started after index 2, so here, and finished after index 4. So we extracted 3 and 4. Now let me show you another way to use the slice method. We can exclude the end index, and with this, we get all the elements in the original array starting from the given index. So that's the second way. And finally, the third way is to exclude the starting index. And with this, we get a copy of the original array. So to recap, if you want to combine two arrays, use the concat method. If you want to slice an array, use the slice method. Now, one thing you need to understand about both these methods is that if you're dealing with primitive values, these primitives will be copied into the target array. But if you have objects in your array, the objects themselves are not copied, the references are copied. And that means the elements in both the input and output arrays will point to the same object. Let me show you what I mean. So for simplicity, I'm going to remove these 3 numbers here and add an object. So an object with ID set to 1. So now we have a reference type, right? When we call the concat method, this object itself is not copied to the combined array. Only its reference is copied. And this means if I go to the first array, get the first element, which is our object, and change its ID to, let's say, 10. Now, when we save the changes, you can see in the combined array, here's the first element, that's our object. note that its ID is changed to 10 as well. So because we're dealing with a reference type, this object is copied by its reference. The same principle applies to the slice method. So as part of slicing this array, if the elements are primitives, they're copied by value. If they're reference types, they're copied by their reference. So in the last lecture, you learned how to use the concat method to combine two arrays. Now, there is another way to achieve the same thing using the spread operator in ES6. So I'm going to rewrite this code using the spread operator, and you will see why this approach is cleaner and more flexible. So I'm going to define combined as a new array. Now we want to combine all the elements of the first array and the second array. So we use the spread operator like this. First and then second. When we spread an array, all its elements are returned individually. So basically here we're declaring a new array, and in that array we're adding the individual elements of the first and second arrays. So this piece of code here is exactly like this. Okay, so you can see with the spread operator, we have a better visualization of how these arrays are combined. It's very clear that we have an array, and in this array, we have all the elements of the first array followed by all the elements of the second array. Now with this spread operator, we have more flexibility. Let's say as part of combining these two arrays, we want to add an element in between them. We can do that easily like this. Or we can add something at the end. Again, we can clearly see what the combined array looks like. In contrast, if you want to do the same thing using the concat method, our code is going to be more complex. So this is how we can use the spread operator to combine two arrays. Now in the last lecture, you learned that if you call the slice method without any arguments, this will return a copy of the original array here. So let's call that copy. Now, once again, we can use the spread operator to copy all the elements of an array into a new array. So we can rewrite this code like this. Constant, copy, we create a new array, and then spread the combined array. So this will return all the elements of the combined array and put them into this new array. So earlier in the section about control flow, you learned about various loops in JavaScript. So in that section, you learned that if you want to iterate an array, you can use the for of loop. So for let number of numbers. Now in each iteration, this number will be set to one of the elements in this array. So let's log that on the console. We get 1, 2, and 3. There is also another way to iterate an array, and you may see that approach in some tutorials online. That is using the for each method. So all these arrays have this for each method that takes a callback function. So we pass a function here. This function takes a parameter, in this case, number. And in this function, we can simply log this number on the console. So when we call the for each method, this function will be executed for each element in the array. Each element will be passed as an argument to this function. So save the changes. Again, we get 1, 2, 3. Now, as I told you before, we can use the arrow function syntax to simplify this code. So we get rid of the function keyword, put a fat arrow between the parameters and the body of the function. And because we have a single parameter, we can remove the parentheses. And finally, we need to remove this semicolon here because we don't have this statement in a code block. So here's the end result. Now, which approach you choose is more of a personal preference. There is really no significant difference between these two ways of iterating an array. The only thing you need to know is that this callback function that we pass to the for each method can optionally take a second parameter, and that's the index. So here, I'm going to put number in parentheses to add the second parameter, that's index. Now, when logging each number or each element, we can also display its index. Save the changes. And you can see the index of each element in front of it. We don't get the index with the for of loop, but if you need that, you can use the for in loop. Again, it's really a tiny issue. Just be aware that we have different ways to iterate an array. Another useful method of arrays is join. So here we have this numbers array. Let's say we want to join the elements in this array. That's when we use the join method. So we call numbers.join. Now look at this parameter here, separator. Note the question mark. Whenever you see a question mark, that means this parameter is optional. And you can see the type of this parameter is a string. So here we can optionally pass a string, and this string will be used as a separator. So let's say we want to join these elements using a comma. So we pass comma as a string here, right? And note that this join method returns a string. So we get the result and store it in a constant called joined. Now let's log it on the console. Joined. Save the changes. So here's the result. Another useful method that goes hand in hand with join is the split method. But this method is not part of arrays, it's part of strings. But let me show you how it works. So let's say we have a string called message like this. This is my first message. Now we can split the sentence like this. So message dot split. Again, here we need to pass a separator string. So let's say we want to separate this using a white space. Now this method will return an array. So let's call that parts. Now let's take a look at this array on the console. Okay, so here's the array. We have 5 elements here. Note that each element in this array is a word in our original message. Now that we have an array, we can use the join method to combine these elements using a separator. So let's say parts.join. We can combine them using a hyphen and store the result in combined and finally log it on the console. So here's the result. This is my first message. This technique is particularly useful when building a URL slug. Let me show you what I mean by that. So here I've got this page open on stackoverflow.com. Read the title of this question, creating arrays in JavaScript. So this is what the user posted. As you can see, we have a white space between each word, but we cannot have a white space in URLs. So if you look at this URL here, note the title of question converted to a URL slug. So all the white spaces are replaced with a hyphen. So as part of converting the title of the question to a URL slug, you'll have to split this string, perhaps throw out some of the words, maybe replace some words with other words, and then eventually combine them using a hyphen, as you can see here. Numbers array. In this lecture, I'm going to change the order of these numbers so they are not sorted, and then I will show you how to sort them. So let's change them to 2, 3, 1 and remove 1 here. Now, how can we sort this array? Very easy. We have this method called sort, and what this method does is that it converts each element here to a string and then sorts the elements in the array. So let's have a look. Console.log of numbers. Here's our numbers array sorted. Now, another method that is often companion to the sort method is the reverse method. And with this, we can reverse the order of elements in an array. So numbers.reverse. Let's log it on the console one more time. Now we have 3, 2, 1. So this sort method is pretty useful, is very easy to use when you have numbers and strings in an array. But when you have objects like course objects, it doesn't work by default. We have to do some extra work. So let me delete this code here and define another array called courses. Here I'm going to add 2 course objects with ID 1 and name, let's say node.js, and another course object with ID 2 and name JavaScript. Now, let's say we want to sort this array by the name of courses. So JavaScript should come before Node.js. So look, if I call courses.sort and then log in on the console, nothing is going to happen. You can see Node is still coming first. So how can we fix this problem? Very easy. This sort method optionally takes an argument, and that's a function that is used for comparison. So when we call the sort method, this method gets two objects in this array, let's say A and B, and compares them. Now, if they are in the right order, it will skip to the next two elements. Otherwise, it's going to rearrange them. So here we need to pass a function for comparison. This function should take two parameters. We can call them A and B, or first and second. It doesn't really matter because A and B is pretty self-explanatory here. Now, in this function, if A is less than B, we should return -1. If A is greater than B, we should return 1. And if they are equal, we should return 0. So to implement this, we can write code like this. If A.name, that's our first course, is less than B.name, we're going to return -1. Okay. Now the second condition, if A.name is greater than B.name, we're going to return 1. Otherwise, we return 0. Now note that here I'm not using else if, because if the first condition is true, with this return statement, we're going to jump out of this function. So the control will never move to this point. So there's really no need to use the else keyword. It's just adding extra noise in the code. So now let's run this code one more time. Save the changes, inspect this array. You can see that JavaScript is coming first. Beautiful. However, if I change this J to a lowercase j and save the changes, see what happens. This time Node is coming first. So what's going on here? Well, each character in a computer is internally represented using a number. Let me show you. So open up Google and search for ASCII table. That is ASC with double I. I remember when I was at university back in Iran, I had this lecturer and he thought these double I's here are 2. So he used to call this ASCII 2. He had no clue that these I's stand for information interchange. So ASCII is short for American Standard Code for Information Interchange. So that's ASCII table, not ASCII 2. Now, take a look at this second link. So on this table, you can see the numeric representation of each character. So we were looking at lowercase j. Its numeric representation is 106. And n, which is used for our node course, is 78. We can see 78 is less than 106. That's why our node course, starting with capital N, came first. Now, to solve this problem, we should exclude case sensitivity when comparing these names. So we can do something like this. We can declare two constants. Let's say name A and set it to A.name to uppercase. So whatever the name of the first course is, we're going to convert it to uppercase. And we're going to do the same with the second course. So I'm going to call the second constant name B and set it to B.name to uppercase. Now we have two uppercase strings. We can compare them. Also take into account that here we could call two lowercase instead of two uppercase. That's perfectly valid. But what is important is that both these names should be either lowercase or uppercase. Now finally, we need to replace the instances of A.name with name A. So I'm going to do multi-cursor editing. I've selected A.name and I'm going to press Command and D on Mac or Control D on Windows. We have this second cursor here, as you can see. Now we can delete this and replace it with name A. Escape. Finished. One more time, I'm going to replace B.name, Command and D, with name B and escape. Done. Save the changes. Now our sort algorithm should work properly. So JavaScript came first. We have two new methods in modern JavaScript called every and some. Very useful methods. So here we have our numbers array. Let's imagine we want to check and see if all numbers in this array are positive. So we call numbers.every, and here we pass a callback function. Here in the IntelliSense, you can see this callback function has 3 parameters. Value, which is a number because here we have an array of numbers. Index, which is the index of this value in the array. And again, that's a number. And finally, the array itself. Now, when writing this function, you don't have to add all these parameters. You can only add the ones that you need. For example, here I'm going to add a function. And I'm only going to add 1 parameter, value, because I don't care about the index of these elements. So we pass this callback function. And in this function, we can check to see if this value is a positive number. So we return value greater than or equal to 0. If this expression, the value is true, we'll return true. Otherwise, we'll return false. Now, finally, this method will return a Boolean. So we can store it in a constant called all positive. So when we call this method, this is what's going to happen. This method will run this function on every element in this array. As soon as it finds an element that doesn't match this criteria, it's going to stop searching. Let me show you. So let's log all positive on the console. You can see it's true because every element or every number in this array is a positive number. However, if I add -1 here, we get false. And basically, as soon as we hit this number, the search will terminate. So if we have a million other numbers in this array, this every method is not going to call this callback function on those numbers. Okay. Now we have a similar method called sum, and that checks to see if we have at least 1 element in this array that matches this criteria. So if I replace every with sum and save the changes, we're going to see true. However, I'm going to change the name of this variable because this is distracting. So always pay great attention to the name of your variables and functions. Make sure they're explaining the right thing. So press F2 and rename this to at least 1 positive. Okay, save the changes, we get true. So this sum method will run this callback function on every element in this array. As soon as it finds an element that matches this criteria, it's going to return true and the search will terminate. So in the current example, if we have a million numbers in this array, because the first number matches this criteria, this callback function will be executed only on this first element. So it doesn't matter what we have after the first element. So to recap, every checks to see if every element in a given array matches the given criteria, and sum checks to see if we have at least 1 element that matches the given criteria. Just to let you know, these methods are new in JavaScript, so some older browsers do not support this. But later in the course, I'm going to explain how to bring these methods in older browsers. I'm going to show you how to filter an array based on a search criteria. So back to our numbers array, let's say we want to return only the positive numbers. So we can use the filter method like this. Filter. Once again, we need to pass a callback function. This function has 3 parameters: value, index, and array. So out of these, we only care about value. We don't care about the index because I just want to see if the number or the value is positive. So function value. Now here we can write a simple expression like this: if value is greater than or equal to 0. So when we call the filter method, this method will loop through this array and execute this callback function for each number, for each element. Now, if the element matches this criteria, it will add this element to a new array. And finally, we can get the new array here. So filtered. Let's take a look at the result. Filtered. So in our filtered array, we have only 1, 2, and 3. Now, earlier you learned about arrow functions. So this is a good case where you would use an arrow function. We have a single line of code in this function, and we're simply returning a value. So we get rid of the function keyword, put a fat arrow between the parameter and the body of this function. We don't need the parentheses because we have a single parameter. And because we're simply returning a value, we can also exclude the return keyword as well as the curly braces, and then put everything on the same line like this. Now we can make this code a little bit shorter. So in this case, we can use an abbreviation like V for value or N for number, because it's obvious that we're working with the numbers array. So we filter and we get numbers where number is greater than or equal to 0. Now here we're dealing with an array of numbers. In a real-world application, you would be using an array of objects. For example, here on the Yelp website, we can click this button to find only the restaurants that are open now. So this is one kind of filtering. So if you want to implement something like this, instead of an array of numbers, you would have an array of restaurants, and each restaurant has opening hours. So you could filter restaurants that are currently open and return them. A very useful and powerful method we have in modern JavaScript is the map method. With this method, we can map each item in an array to something else. So following from the example in the last lecture, we have an array of positive numbers. Let's say we want to construct some HTML markup using the elements in this array. So we call filtered.map. And once again, we need to pass a callback function here. This function, just like the function that we passed to the filter method, can have 3 parameters: value, index, and array. So in this case, again, we're going to work only with the value. So we can pass a function or an arrow function. So we get a number, and then we want to map this to some HTML markup. So we can add a string in an opening list item element, then we add the number, and finally the closing list item element. So with this markup, we can display each number using a bullet point. Of course, we need to put these inside of a UL element, and I'm going to show you that in a second. So let's see the result of the map method. I'm going to store the result in a constant called items. And now let's display this on the console. So you can see each number is now mapped to a string. That's our list item. So now we have an array of strings. We can use the join method that you learned about earlier to join the elements of this array and create a string. So constant HTML, we set it to items.join, and then display this on the console. Now, instead of an array, we have a string. Note that by default, comma is used as the separator. We don't want to have comma in our HTML markup. We just want to combine these using an empty character like this. Save the changes. Now comma is gone. The only bit that is remaining is the UL element. So a very simple implementation would be like this. We add UL, then concatenate it with all these items, and finally another UL. Save the changes, and here's our HTML markup to display all these numbers using bullet points. Now later in the course, I will show you a more elegant way to implement the same thing. All I want you to take away from this lecture is that we can use the map method to map each element in an array into something else. Now in this example, we are mapping these numbers to strings, but you can also map them to objects. Let me show you another example. So I'm going to delete this HTML. Let's expand this a little bit more. So instead of mapping a number to a string, let's say we want to map them to an object. So here I'm going to define an object. In this object, we want to have a value property, and we want to set that to this number. And finally, we want to return this object. Let's look at the result. Oops, I made a mistake. I deleted the HTML constant, and that's why we get this error. HTML is not defined. So let's display the items constant. Now here is the result of our map. We mapped each number to an object with a value property. Okay, it's very useful when building real-world applications. Now, let me show you something tricky here. In our callback function, we are declaring this constant and then returning it. Technically, we don't need to declare this as a separate constant. We can simply put the return keyword here and return this object because we're not working with that constant, with that object constant, okay? So save the changes, we'll still get the same result. Now, earlier I told you that in your arrow function, if you have a single line of code and you're returning a value, you can exclude the return keyword as well as the curly braces. So let's do that and see what happens. So remove the return keyword and the curly braces, then put everything on one line like this. Now, if we save the changes, we don't get the same result. We get an array of 3 undefined elements. The reason for this is that by default, these curly braces in an arrow function represent a code block. So when the JavaScript engine tries to parse this arrow function, it thinks here we're defining a code block as opposed to an object to return. So if you're returning an object, you need to put that object in parentheses, like this. So we put this object in parentheses. And with this, our JavaScript engine will not look at this as a code block. Now save the changes. Now, once again, we get 3 objects. And one last thing before we finish this lecture. So you have noticed that both the filter and the map method return a new array. They don't modify the original array, okay? Now, these methods are chainable, which means we can call them one after another in a chain. So in this case, this filtered constant is only used here. We haven't used this anywhere else in the code. So we don't have to explicitly store the result of this statement inside a separate constant. We can get rid of this. We call the filter method. Now, we don't want to have a semicolon here because we are not going to terminate this statement. Instead, we're going to immediately call the map method on the result that is returned from this statement, okay? So I'm going to copy our map method here. This is what we call chaining. So we're calling one method. That method returns some result. Now we're immediately calling the map method on that result. Now, when chaining multiple methods, by convention, we put each method call on a separate line, and this makes our code cleaner. Have a look. So numbers.filter, and then .map, and so on. And finally, we store the result in the items. That's a better and cleaner code. Save the changes, we still get the same result, right? Now note that here, because the map method is returning a new array, again, we can call the filter or the map method on that array. So here we can call the filter one more time. We get an object, and maybe we want to get objects with value greater than 1. See what happens? Now in the result, we have only 2 objects in our array, objects with value 2 and 3. And again, we can call the map method and maybe map each object to a number. So we read the value property and return it. Save the changes. Now we have an array of 2 numbers. So this is the power of chaining these methods. Again, with our array of numbers, let's say we want to calculate the sum of all these numbers in this array. This would be similar to calculating the total cost of all the items in a shopping cart. So each numbers here could represent the price of an item in a shopping cart. Of course, we wouldn't have a negative number there, but you got the point. So here's a very simple algorithm for calculating the sum of all the numbers in this array. We start by declaring a variable called sum, and we initialize it to 0. Next, we loop over this array, get each element or each number, and add it to sum. Something like this. For let n of numbers. Now we want to add n to sum. So we can write an expression like this. Sum equals sum plus n. Or a better way is to use the addition assignment operator. So we can exclude the second sum. So this is exactly like the statement we had before. And finally, we display sum on the console. So we get 5. Now there is a cleaner and more elegant way to write the same code using the reduce method in arrays. So all these arrays have this reduce method, and with this method we can reduce all these elements in an array into a single value. That single value can be a number, it can be a string, it can be an object, it can be anything. In this example, we want to reduce all these elements into a single number. That is the sum of all the numbers in this array. So let's see how we can use the reduce method. This method takes a callback function with 2 parameters, accumulator and current value. So here I'm using an arrow function like this. This accumulator parameter here is exactly like this sum we have here. It's something that we initialize, and then this callback function is executed multiple times. Each time this current value will be set to one element in this array. Okay, so in each call we want to get this current value and add it to accumulator. So we simply return the sum of accumulator plus current value. Now internally, this reduce method will get this result and store it in the accumulator. You will see that in a second. Now one last thing we need to do here is to initialize this accumulator to 0. So as the second argument to the reduce method, we pass 0. Note that this reduce method has 2 arguments. The first argument is a callback function, and the second argument is the initial value for the accumulator. Finally, we get the result as a single value, in this case, sum. Now we don't need this code anymore. And finally, let's bring this console.log here. Save the changes. You can see we get the same result, 5. But let's see what exactly is happening here. So initially we set accumulator to 0. So I'm going to set a equals 0. In the first round, current value will be set to the first number. So c equals 1. Now we add this together. So we get 1, and a will be set to 1 after this callback function is executed. So as a result, a will be 1. Now in the second round, a is 1. Current value will be set to the second number in this array. So -1. Now once again, we add them together. So a will be 0 after the second call. Now the third call. So a is 0. The current value is going to be set to the third element in this array. So 2. And as a result, a will be 2. And finally, in the last call, we start with a set to 2. And current value will be 3. Okay? So the result will be 5. And that's why we saw 5 on the console. So essentially, with this reduce method, we start with an accumulator. Then we loop through this array and convert all these elements into a single value, which is in this case, accumulator, or the sum of all the numbers in this array. Now we can make this code even shorter. We can exclude the initialization of the accumulator, and with this, accumulator will be set to the first element. So let me show you what will happen. A will initially be set to 1, and current value will be set to -1. That is exactly like our second call here, right? So as a result, a will be set to 0. Now, in our second round, a will be 0, and current value will be 2. Because in the previous call, current value was here, so now we are here. So current value will be 2, and as a result, a will be 2. And finally, in the last call, a will be 2, and current value will be 3, the last element in this array. And once again, we get 5. So if we supply an initial value, we'll have one more call. If we don't, the first element in this array will be used as the initial value. So this is how the reduce method works. And finally, to make this code a little bit shorter, we can get rid of this return keyword because we have a single line and we are simply returning a value. So remove the return, the semicolon, and the curly braces, put everything on a single line like this. So with this single line of code, we reduce the numbers array, and this is how our reduction algorithm works. We simply get the current value and add it to our accumulator. This is far cleaner and more elegant than declaring a sum and then looping over this array, like let n of numbers and then add n to the sum. That's a very old way of writing code. All right, so we have covered a lot about arrays. Now it's time for some exercises. Here's our first exercise. I want you to write a function called array from range. This function should take two parameters, min and max, and this is how we can use this function. So when we run this program, we get an array, and in this array we have numbers from 1 to 4, as you can see here. We can also pass a negative number here, let's say from -10 to -4. So we'll get an array like this. So pause the video, spend 5 minutes on this exercise, and when you're done, come back, continue watching. All right, so I'm going to define a function called array from range with min and max parameters. Here, first we should create an empty array. So let's call that output and set it to an empty array. Now we need a for loop to generate numbers between min and max. So for let I equal min. As long as I is less than or equal to max, we're going to increment I and then push this I into our array. So output.push I. And finally, we return this output. Now let's test this. So save the changes with -10 and -4. These are the numbers we get. If we pass a positive number like 1 to 4, here's the output. If the maximum value that we supply is less than the minimum, we get an empty array. All right, now our second exercise. So here we have an array of numbers. You have seen the includes method before. So console.log numbers.includes. With this method, we can check to see if a given element exists in the array. Now, your exercise is to write a function like the includes method. So imagine we don't have this method in arrays. Your job is to implement this method yourself. So I want you to create a function called includes that takes an array and a search element. If we have the search element in the array, we should return true. Otherwise, we should return false. So pause the video, do the exercise, and when you're done, come back, continue watching. All right, so here we need to iterate over this array. If we find an element that equals the search element, we're going to return true. Otherwise, we're going to return false. Very, very easy. So for, we're going to use the for of loop. So for let element of array. Now, if element equals this search element, we're going to return true. So we don't need to search the rest of this array. We immediately return true. Otherwise, if we get to this point, that means we didn't find this element in the array, so we return false. Now let's test this. So I'm going to call the includes function, pass our numbers array as the first argument and 1 as the second argument. Obviously, we have this number, so we get true. But if we pass -1, we get false. Here's the third exercise. So we have this numbers array and a function called accept that takes an array and another array. And in this array, we can add the values we want to be excluded from the original array. So this function returns a new array without the values that we have passed here. So if you run this program, we get a new array with these 3 values, 2, 3, 4, because we excluded 1. Note that it doesn't matter how many 1s we have here, so I can add a couple more 1s and we still get the same result. Or we can add multiple values here. So let's say we want to exclude 1 and 2. So as a result, we'll get 3 and 4. So get started. You will see my solution next. All right, here we need to declare an array called output and initialize it to an empty array. This is what we're going to return from this function. Now we need to iterate over this original array. And for each element, we have to see if that element is in this other array. If it's not, then we will add that element into this new array. Okay? So for let element of array, we iterate over the original array. Now we should see if this excluded array includes this element. So basically we're checking to see if the current element is in the excluded array. If it's not, so we apply the not operator, then we will add this element into our output array. So output the push element. And finally, we'll return output. So save the changes. If we exclude 1 and 2 here, we'll get 3 and 4. If we exclude all numbers 3 and 4, we'll get an empty array. Exercise is a little bit tricky, but trust me, it's absolutely worth spending time on it because it trains your programming brain. So we have this function called move, and we use that to move an element in an array. So this is how it works. We give it an array, the index of the element we want to move, and an offset. So in this case, I want to move the first element in this array, that is 1. Now I have passed 0 as the offset. So with this, nothing is going to change. We're going to get the same array. However, if I pass 1 as the offset, see what happens here. So 1 moves 1 position to the right. If I pass 2 as the offset, 1 ends up here. If I pass 3, it ends up being at the end of the array. If I pass anything more than the length of the array, that is 4, I get this error, invalid offset. Now to display errors like this, you should use another method called console.error. So you simply pass a string and that will end up appearing as a red message on the console. Now also note that this offset can be a negative number. So let's say we want to move this second element 1 position to the left. So we set index to 1 and offset to -1. So 2 moves to the beginning of the array. If I pass -2 as the offset, because it can't jump out of the array, once again, we're going to get this error, invalid offset. Also note that in all these examples, the original array is unaffected. So we get a new array with items reordered. So spend 10 to 15 minutes on this exercise. And when you're done, come back, continue watching. All right, so I've reset these numbers to 0 and 1. So we want to move the first element in this array 1 position to the right. The first thing we want to do is to copy this array because we don't want to modify it. So that's where we use the spread operator. I'm going to define a constant called output, set it to a new array, and then I'm going to spread the original array. So this will be a clone of the original array, okay? Now, as part of moving an element, first we need to remove it from the array, and then we need to place it back at the right position. To remove an element from an array, we use the splice method. You have seen that before, splice. So we go to the given index and delete one item. Now look at the return value of this method. It returns an array. So the items that are removed will be returned as an array. In this case, we're removing one item so we can access the first element in that array, and that will return the element that we just deleted. So let's store that in a separate constant. The reason I'm storing it here is because next we need to add this back to the array. Now we want to add this at a specific position. Once again, we need to use the splice method. So output.splice. Now where are we going to place this? We want to go to index plus offset. Now we don't want to delete any items here, so we pass 0. And finally, we pass this element that we want to place in the array. And finally, we return the output. Let's test this. So if we move the first element one position to the right, we get the right result, beautiful. If we move it 2 positions to the right, it ends up here. If we pass 3, it ends up being at the end of the array. If we pass 4, we don't get the error that I told you should produce, but the output is still the same. Now to solve this issue, we need to come back here and do some basic validation before running this algorithm for moving an item. So we can do something like this. We define a constant, call it position. That is the new position, right? And that's going to be index plus offset. Exactly the same value we have used here. So we can replace this expression with position. Now we have position. We can check to see if position is greater than or equal to array.length. So in this case, our array has 4 elements. If we pass 4 or a greater value, we should see the error on the console. So here we add the code block, console.error, invalid offset. And finally, we return. So the rest of this function is not executed. The other option would be to have an else block here, but that means we have to put this code inside this block. There's going to be a bit of indentation. This is really unnecessary because if we return here, none of the code here will be executed. So we can get rid of the else keyword as well as the code block and extra indentation. So if we pass 4, we should get the error, beautiful. Now let's pass 0. So we're not going to move this element. We get the original array, beautiful. If we pass -1, we get some weird result. In this case, 1 should not jump out of the array. So we need to change our validation logic here to something like this. So if position is greater than or equal to the length of the array, or position is a negative number, then we should display the error. So save the changes, beautiful. Now let's test this with another value. So I'm going to work on the second element here. So let's change 0 to 1. We're going to move this 1 position to the left, save the changes. 2 comes here, beautiful. If we pass -2, again, we should get the error. Here is the error, perfect. Now let's change this back to 0. So we get the original array. If we pass 1, 2 moves here. If we pass 2, 2 moves to the end of the array. If we pass 3, we should get an error. And here's the error, beautiful. All right, now I want you to create a function called count occurrences. This function takes an array and a search element and returns the number of times that search element has occurred in this array. For example, here in our numbers array, we have a single instance of 1. So if we call this function and pass 1, we get 1. If I add another 1 here, now you can see we have 2 instances of 1. Or if we call this function with a number that does not exist in the array, we get 0. So start with the simplest implementation for this function. Once you get that working, then to challenge yourself, implement this function using the reduce method in arrays. Because here essentially we are reducing this entire array into a number. And that number represents the number of times a given element has occurred in our array. You will see my solution next. All right, here's the basic implementation. So we declare a count variable and initialize it to 0. Now we need to iterate over this array. And if you find this search element, we're going to increment count. At the end of this function, we'll return count. Very easy. So for let element of array. Now, if this element equals the search element, we simply increment count. And finally, we return count. So that's the most basic implementation. Now let's see how we can use the reduce method to achieve the same thing with less code. So instead of this implementation, we're going to use array.reduce. Here we need to pass a callback function with 2 parameters, accumulator and current. And this goes to this code block. So this accumulator represents the number of times this search element has occurred in our array. So I'm going to initialize this to 0, like this. Now, every time this callback function is called, we want to compare this current value with search element. If they are equal, we should return accumulator plus 1. Otherwise, we should return accumulator. So we can do something like this. We define a constant called occurrence. Now, if current equals search element, here I'm going to use the conditional operator. So if they're equal, I'm going to add 1 to accumulator. Otherwise, I'm going to add 0 to accumulator. And finally, we're going to return accumulator plus occurrence. Now, let me show you how this works. So let's do a console.log. We're going to log 3 values. One is our accumulator, and the other 2 are current as well as the search element. And one last thing we need to do here is to actually return this value. So let's inspect this program. We save the changes. Here in the console, you can see this callback function has been called 5 times. 1, 2, 3, 4, 5. And here's the result, because we don't have -1 in this array. Now let me change this to a value that we have so you can see exactly what is happening under the hood. So I'm going to change -1 to 1, save the changes. Now let's see what's happening. So in the first round, our accumulator is 0, current is 1, so is search element. So accumulator is incremented by 1. So in the second round, accumulator is 1, current is 2, and our search element, as we can see, is always 1. Now in this case, these two numbers are not equal, so accumulator is not changed. So we simply return accumulator plus 0. We want to make sure to keep this number as we go through this array. Now finally, in the last call, you can see accumulator is still 1, and in this case, the current value and the search element are equal, so accumulator is incremented by 1, and that's what we get out of this reduce method. Another exercise. In this exercise, I want you to create this function, getMax. We give it an array, and it returns the largest number in that array. So if we give it this array of numbers, it returns 4. If we give it an empty array, it returns undefined because we don't have anything in this array. So we cannot return 0 or a negative number because none of these values exist in this array. So go ahead, do this exercise. Start with a simple implementation. Once that implementation is working, then to challenge yourself, implement this function using the reduce method in arrays. You will see my solution next. All right, so let's start with the simplest implementation. First, we want to check to see if this array is empty or not. If it's empty, we're going to return undefined. So if array.length equals 0, you're going to return undefined. Also note that by convention, sometimes if you have an if statement with only one line after, some developers prefer to put that line right next to the if statement. Some developers format it like this. It's more of a personal preference. There's really no right or wrong. So I'm going to put this on the same line. Now, otherwise, we have at least one element in this array. So I'm going to declare a variable, call it max, and set it to the first element in this array. So we want to assume that the first element is the largest number. Next, we will iterate this array. And if we find a number that is larger, then we're going to reset this max variable. So let's do a for loop. Let we start from the second element in this array and run this loop as long as I is less than the length of the array. Then we increment I. Now we need to check to see if the current number is larger than max. So if array of I is greater than max, then we're going to set max to this current value. Okay. Finally, after this loop, we want to return max. So that's the simplest implementation. If you run this code and pass an empty array here, we get undefined, beautiful. If you pass an array with only one number, we get that number. If we add two numbers here, 2 is the largest number. Let's add a few more values here. Now we should get 3. Beautiful. So our basic implementation is working. Now let's re-implement this method using the reduce method. So we want to keep the first line as is. So if we don't have anything in this array, we want to return undefined. Otherwise, let me comment out this code so we can compare them side by side. So we use array.reduce. We pass an arrow function with two parameters, accumulator and current. And that goes to this code block here. So you know that if we don't pass an initial value for the accumulator, by default, it will be set to the first element in the array. That is exactly like what we have on line 11. So in the body of this arrow function, we want to check to see if the current value is greater than what we have in accumulator, exactly like what we have here. If it is, then we want to return the current value. Otherwise, we want to return accumulator. So we can write code like this. If current is greater than accumulator, we want to return current. Otherwise, we'll return accumulator. Now we can rewrite this using the conditional operator. So let me expand this. So instead of these two lines, we can do something like this. Return, we add our condition, which is current greater than accumulator. If that's the case, we want to return current. Otherwise, we return accumulator. That is cleaner, right? Now we can make this code even cleaner by renaming these two parameters to something like A and B. So basically, we're reducing this array. We get two elements at a time. If B is greater than A, we're going to return B. Otherwise, we're going to return A. Actually, I personally prefer to change the order of these operands. So I would like to say if A is greater than B, then I want to return A. Otherwise, I want to return B. That is very easy to understand. Also, because we have a single line of code here, we're simply returning a value. We can get rid of the return keyword as well as the curly braces, bring everything on one line. And here's the end result. So basically, you can see this line of code is equivalent to all these lines here. That is the beauty of the reduce method. So this is what I want you to take away from this exercise. Anytime you have an array of values and you want to get a single value as a result of iterating that array, think of the reduce method. In this case, we're finding the largest value in this array. So we're reducing this array into a single value. All right, and finally, we need to return whatever we're getting from the reduce method. Now, let's test this and make sure everything is working. So I'm going to save the changes. We still get 3. If I pass an empty array, we get undefined. Beautiful. Exercise is a little bit different from the exercises we have done in this section. I want you to code along with me like this. So let's declare a constant called movies. We set this to an array of objects. In this array, we're going to have 4 movie objects. In each movie, we're going to have 3 properties. Title, set the first one to A. And then the second property is year. We set this to 2018. And the third property is rating, which we set to 4.5. Now let's duplicate this a few times. So hold down Shift, Alt, and the down arrow. With this, we can easily duplicate the current line. Now change the title of each movie. So the second one is going to be B, and then C, and then D. Let's change the year of the last movie to 2017. And finally change the ratings to 4.7, 3, and 4.5. Now with this array of movies, your exercise is to write code to get all the movies in 2018 with rating greater than 4. I want you to sort them by their rating in a descending order. So movies that have a higher rating should come first. Then I want you to only pick their title property and display it on the console. So the result should be B and A. That is what you should see on the console. So go ahead, spend 5 minutes on this exercise, and you'll see my solution next. All right, so we want to filter movies by their year and rating. So movies dot filter. Here we pass an arrow function. So m, as in short for movie, goes to m.year should equal 2018, and m.rating should be greater than or equal to 4. So that's the first part, our filtering. Next, we want to sort them by the rating. So as you learned earlier, these methods are chainable because filter returns a new array, so we can immediately apply the sort method on that array. Now, as you learned earlier, this sort method by default only works for numbers and strings. For objects, we need to supply a comparison function. So here, once again, I'm going to use an arrow function that takes A and B. So these are two movie objects in our movies array. So A and B goes to, now basically, if A is less than B, we want to return -1 or a negative value. If they are equal, we want to return 0. And if A is greater than B, we want to return +1 or a positive value. A simple way to implement this is like this. So I'm going to delete all this and the curly braces. We simply get the rating of A and subtract it from the rating of B. So let's say the rating of A is 4.5 and the rating of B is 4. When we subtract A from B, we'll get 0.5. That's a positive number. So that means A is greater than B. Now, if both these ratings are equal, we'll get 0. And that means A equals B. So we don't need 3 if statements here to return -1, +1, or 0. Okay? We simply subtract these values. Now, this sort method returns values sorted in an ascending order. But what we want here is descending order. So we need to call the reverse method to change the order of these movies. And finally, to pick only their title, we want to use the map method. So map, we get a movie object to pass an arrow function. So m goes to m.title. That's the code you should have written. So let's store the result in a constant called titles, and finally display them on the console. So we get B and A.